I'm working at Adobe. I'm a computer scientist, and I'm working on the web engine team with Divya. That's my Twitter. Okay, I got it. So that's my Twitter handle if you want to follow me or something. And at Adobe, I've been working on most of the features that we proposed, features like CSS regions, exclusions, or filters. And most of the time, you can find me on the WebKit RC channel. I'm usually hacking on WebKit. So today I'm going to talk about CSS FilterLab, but before that, how many of you have heard about CSS filters? All right, cool. So most probably you already know that CSS filters are a way of applying visual effects on the web. If you wonder why would you need that in the browser and not, I mean, that's been possible before using tools like Photoshop or other tools that were available offline. And what people did before was just embed the filters directly in their assets. So they generate the PNGs or JPEGs using directly sepia or brightness or other filters. But now we have this option to do it in the browser, and you can apply the filter effect on any element of the DOM, meaning that you can take a form or some image or any other text or any other block elements and apply some filters. And that's pretty cool because you can customize your content exactly how you want it to be viewed by that specific user you're targeting. And one thing that it's good to know is that filters can be chained, so you can have a blur and apply a sepia, other manipulations, color manipulations that you may want. And because this is hardware accelerated in most implementations, you can animate it really nicely and get some nice effects on it. And one thing that you need to know is that there are 3 types of filters that can be applied on elements. The first one is the most common. They're the built-in filters. There are 10 filters that are available today in some of the browsers, like Safari 6. iOS 6 also has it, and Chromium. And they include things like drop shadow, blur, or other color manipulations like brightness or sepia. The second type that we at Adobe are working on is the custom filters. It's actually about writing your own filter for the web. You can use the same programming language that WebGL uses. So with custom filters, you can target directly the graphic unit, the GPU. So it's all about writing shaders, and you can get some nice effects like page curling or warping. You can desorb the elements in so many ways. And the third type is actually bringing the complex SVG filters that were possible today in most browsers. And with the SVG filter reference, you can now reference an SVG filter from CSS, meaning that now you can apply the SVG filter on any other element that's not an SVG element. So you can take an old SVG filter and just put it on a block or a button or something else that you may have in your document. So now I've prepared a demo here where I have this image in the middle, and I have a demo with this filter blur in the middle. This is the CSS for this filter. The CSS property is called filter, and all the filters are actually custom functions like this. Blur is just blur, and you can change them. If you used the transform property before, it's pretty similar to that. You can put multiple of these effects, and we are going to take the input from one effect and put that in the input of the output of the first input is going to be in the next one. And by the way, I'm using the presentation is all built in HTML, and I'm using an iPad here. So everything that you see, like the circles that you see on screen, are actually my fingers. So I'm going to drag this here, and you see that syntax changes. It's changing the value of the blur parameter, and you can see the image is being updated in real time. And as I told you, you can apply this on other elements, like the form. So in this case, I have this element. I can go on and type on it and go back. Oh, sorry about it. And you can still see the content. I mean, there it's live content. First phrase from the specification itself, it's just text. You can still see how it is selectable. that, I can still blur it, and I get the exact thing I want. So, okay. Now back to CSS FilterLab. At Adobe, whenever we think about a new feature, we usually want to make sure that the API that we expose and the syntax is really useful in practice. So what we do, we build demos and applications just to work with the syntax and the new feature. And in this case, for filters, we built a couple of demos, but then we realized that we really want something like a tool where you can play around with the parameters and move filters around. And we ended up with CSS FilterLab. It is initially just an experiment to see how it works, but it ended up as a tool that designers can use to create these effects and animate their filters. And it's available online. You can download it. It's on the GitHub. It's actually a web application, so you don't need to download it to run it, but you can, it's open source, so you can look at the code. And today I'm not going to talk about that one, but I'm going to talk about what we did to move FilterLab on mobile. So here I have, on this side, I have the screenshot of the FilterLab for mobile. So what I'm going to do right now is going to switch. I have FilterLab here. It's a home screen app, so it's using the offline cache, so it's on my tablet. And when it starts, it just has this preset mode. You have all the presets that I created before, and the preset is just a list of filters. So whenever you're done with customizing your filters, you can share it, you can save it, or do something else with it, or encode it in your app. So I'm going to go ahead and open the first preset. Right now, there's no filter in the list, so I can bring up the filter list. We have the built-in filters today, and this is the stock iOS 6. So you see all the filters are already supported. The built-in ones are here. So I'm going to go ahead and select the sepia. And right here, I have this control on the button that I can use to change the effect, but that's not really useful if I'm changing this effect and I cannot see it. So what we did was to use the UI to expose the exact filter that you're editing. So on the lower left corner, hopefully you can see that around there. It's this filter sepia 91%. So I can still go ahead and play around with the filter and see the results in there. And I was telling you that you can combine filters, so you can change them. So what I can do right now is go ahead and add a saturate. And what that does, if you see here on the left corner, the sepia and saturate can be combined and work together. And I can go back and change this guy to, and exactly what I want to do, build my own filter. And at the end, if I don't like one of the filters, I can keep my finger on it and remove it, and it goes away. And we actually wanted to see how it works on mobile and see how the touch interaction works. So for example, in this case, I can go ahead and go back to my presets by just scaling down and move around, or just scale it up, back up. And I think this is pretty much it for FilterLab. So I'm going to go back to my presentation here and talk about what it took us to build that mobile application. First of all, I want to mention Grunt.js. We didn't use it from the beginning, but it's really useful. Initially, we just had one build for desktop, but now we're building both desktop and mobile from the same sources. So Grunt.js is a build system written in JavaScript itself. So it's really useful if you are a web developer and you know JavaScript, then Grunt.js it comes really handy. And offers all sorts of things like compiling from some templates or linting your script. So it's really cool. And we're actually using it to build everything right now. Another cool tool that I use is the Adobe Edge Inspect. So if you're targeting multiple devices at the same time, what I usually do is I have 5 devices around me. And this is really cool. You can refresh on your computer, and automatically it updates everything else. And also has this interesting feature where you can remotely debug your elements and CSS properties and see how they're applied, compute the margins, and see how your UI is not behaving well sometimes. So it's pretty useful for that reason. And now I'm going to talk about the web features and not about the tools. And I think we already covered offline tools, offline features today. But I'm just going to go over it really quickly. We had to think about the mobile UI again, because on desktop you have so much space. FilterLab was designed for desktop because designers are usually using a desktop machine. But whenever you have the small screen of a device, you want to make sure that buttons are larger and you use the whole space to let the user see the whole image and not put all sorts of controls and just have a small document in there. And it's also about the gesture recognition, things like scaling down, scaling up, scaling back up, things like lists and scrolling. And also, we had to think a little bit more about performance. On desktop, usually the machines are really fast, but whenever you move to mobile, you've seen the presentation before where mobile is not exactly the same as desktop. So it's a good thing to know how to optimize your application for mobile in that case. So I'm going to talk a little bit about workers and maybe request animation frame. Okay, so really quickly, application cache, we've used that so that, for example, this presentation is also built in HTML5. So what I did in order to avoid having problems with the Wi-Fi, I installed this application cache manifest file. And it's really cool. I don't have to download, and I'm pretty sure that the thing is going to load next time I'm looking at it. And there are some problems that we had initially with application cache. Just getting it ready was, actually using it was a little bit of a problem. And there's an article online that you could use and see what are the things you need to avoid whenever you enable application cache. Things like getting stuck with a specific version. And if you read that blog, you can avoid it really easily. Also, for the presets and all the filters, we've used the web storage, the local storage. We store settings, and we've seen that it's pretty limited in size, so it's not really good at storing images or things really big. But there were presentations about it before, so I'm just going to quickly skip it. So about the gestures that we wanted to implement in FilterLab, we actually identified 3 basic things that you want to support. And things like, easy things like tapping. This is the equivalent of the click on a desktop machine. But you also have this long hold, which is most probably the equivalent of the right click on desktop, but usually you want to use it in a different way. You also have dragging around, where you can have either horizontal dragging or vertical dragging. And also this thing where you can pinch and zoom, and you want to transform that scales or rotations, and be able to use it in transforms and apply it to elements. And as I said, those are just the basic ones, but what you can do, you can combine all of those into a single element. So we still have these things that can be tapped. You can still hold and wait, but you also can drag it around. And one more thing, you can scale it up and down and move it around. And one more thing that it's doable whenever you have multi-touches, you can move both at the same time. And you can actually get to lots of problems when you have scrolling enabled. So in this case, we're using just the horizontal scroll for the lines, and you can move around all the lines. But whenever I'm starting to scroll vertically, it's just going to stick around and just move vertically. It's not going to move the line anymore. And what you can do more than that is whenever you have 2 touches, we can combine all the gestures that we had before, so we can move this around and follow you. Another feature is, the tap still works, but what you can do is you can use the long hold to do something else, like dragging the item after your finger. So what does it take to do that? We quickly identified that we want to build this app to work on desktop too, because that's where we want to debug it most of the time. So we wanted to be able to use the whole application using just the mouse, even though you have to do all sorts of gestures with your mouse, which are a little bit more uncomfortable, but we're not targeting the desktop for the real user, but we use it for debugging. So we're still listening for the mouse events. Also, you're targeting the touch. So most of the devices out there, they have touch events, so you have to listen for the touch events too. And on IE10, we actually target multiple devices, and some of the devices they have both mouse and touch at the same time, and some of them have pan too. So pointers is a new specification that comes along with IE10, and they actually support all the interaction models in one single API, which is pretty cool, and I hope other browsers will pick it up soon. So what you need to do is take all those events and build this user interaction framework. A cool thing about IE10 is that they already support all of that using just native CSS and JavaScript. Again, I hope that that's coming to other browsers too. And they have these CSS properties we can define. Oh, this is going to be scrollable only vertically, or this is going to be scrollable horizontally, or I want this to be manipulatable with 2 fingers. Or you want to, you can actually have this gesture class that you can use to to detect gestures in your JavaScript if you want to handle more complex gestures. So on other devices, you have to implement your own stuff. So what happened? We implemented this and quickly identified the problem of having all these touch events spread around all the elements. So what I did was to collect all these gestures into one single place so that we can detect whenever you have one touch on one element and the other touch on a different element. You still can apply scaling and know that they're coming from the same thing. So whenever you start a gesture, you want to make sure that the ancestors are not really interested to handle that gesture first. For example, we had scrolling with vertical scrolling and horizontal scrolling. Whenever you start dragging around, you want to make sure that the right element receives the right gesture. And also, one interesting thing that we used was to actually see the fingers. And for example, on some devices, I got the touch start event twice, and that blew up the whole application at some point. And using this thing, you can see, oh, that touch pointer actually got stuck or was still there and I couldn't handle it or something like that. So you can kind of get some debugging information out of it. So we had all these touch events. We had all the interaction. The only problem we had was that the performance was not that good on moving things around. So one thing to keep in mind whenever you're building for mobile is that WebKit-based browsers in general have only 3 properties that are hardware accelerated, and they all start from the transform. If you're setting the transform property, then the browser is going to move the whole element to the GPU side. The GPU is the graphical unit. So what happens is that you'll get really quick animations because the GPU is really designed to do that instead. So if you set also opacity and filters, they're committed also on the GPU side, so they're really good at it, and you get a lot better at performance. Also about loud, usually it's good to avoid triggering any louds, especially during animations. But if you have to actually do something and move things around, I would recommend using the obsolete positioning. Usually what happens is that browsers are really, really optimized for handling this case. And it's really easy to compute anyway. It's like you set the left and top, and it already knows what happens with that element. Also, another thing that's useful is to keep the children count per element really low. What happens is that usually browsers are trying to avoid doing loud for things that they know it's not really needed. So if you have like lots of elements in one element and only one of those requires a loud, it will kind of trigger the loud on others too. So it's good to avoid having lots of them so that you can kind of let the browser optimize the whole loud process. Also, it's good to note that things like box shadows are not optimized on some of the browsers. And they're really slow if you have dynamic content. So if the content changes a lot, it's usually a good thing to avoid box shadows. And now with filters, you can use the drop shadow filter instead, which is a lot faster on some of them. Also, if you have JavaScript that kind of runs your loud, it's usually a good thing to avoid requesting things from the loud, like a client width or client height. Whenever you're doing this. Because what happens is if you change a CSS property and then you request client width, for example, the browser will try to do the loud so that it computes correctly what the value is for that element. And one way to avoid that is to do this lazy CSS technique where you collect all the CSS changes in a list and only apply them whenever the request animation frame comes back to you. And this way you avoid doing multiple layouts. You only trigger one layout at the end, and it's synchronized with the screen, so it really gives you a good performance. For example, all the visualizations in here, that like the circle that is following my finger, that's moved on the request animation frame. So it's really synchronized with the device. It's synchronized with the display, so you get really good performance with it. And if you think about the touch events, you usually get a lot of touch events. It's a lot more than the frame rate of your device. So what you want to do is avoid updating your screen for every single touch, and only update it when the screen really wants it to be updated. Also, so CSS selectors might be slow sometimes. What happens is that whenever you have CSS selectors in your style sheet, the browser needs to apply that to the elements, and they need to match it from the CSS style sheet with the elements. And if you have really heavy selectors that really take a long time to check, the browser will do that all over again. Whenever you change anything in the DOM, it's going to try to match it with all the CSS selectors. Browsers usually have optimizations in place. So if you have a specific class name, the browser can just look that up. It's a hash map. It's really quickly. If you use that, it's going to be really performant. And one case that is really not performing well is whenever you have deep indirect ancestors. For example, sometimes I've seen in applications where they have some sort of a class on the body element, and they change the whole screen whenever changes on the body element. And that's usually bad because all your elements are going to try to match that body tag, which is a lot. It's very like so many elements from your leaves to the body, so it will try to match it with all the ancestors until it reaches the body, so it takes a lot of time. And one more generic selector, like I have this here an example where you have the calendar view div. What happens, the browser is going to try to apply this selector with all the divs in the DOM. And sometimes you end up having really lots of divs in the DOM. So what happens is going to try to find the calendar view as a parent of that div, of all the divs actually. And most probably 90% of your divs in the DOM are not going to match that selector. But it's still going to try to fix it and try to see if it really matches or not. So it takes time. Also, there are so many advancements in the CSS selectors world, but not all of them are performant. For example, the sibling selectors, what happens is that whenever you set a sibling selector, it will set a flag on the parent saying, next time you have a new element added to this list, let me know so that I can check again if you're not changing the odd even or something else did not change. So most of the elements in that list are going to get different, we're going to try to recompute their style. So usually it's not a good thing to do. Yeah, about performance, I really used a lot of 3D transforms in CSS FilterLab, but you need to make sure that you're not abusing it. Whenever you have a 3D transform on an element, it's just going to use some GPU memory to cache the result of drawing the element. So, you know, the GPU memory is limited on devices, so what happens is that some of the browsers are just going to crash. For example, in this presentation framework, I'm only displaying the previous slide, the current slide, and the next slide at all times, so that the GPU is not going to be polluted with all the slides that I'm not looking at. Otherwise, for example, in this case, the Safari is just going to crash. It's not telling you anything, so it's a good thing to know that it might crash whenever you're out of memory. So whenever that happens, you may want to look around and see how you want to optimize that and reduce the number of layers that you applied 3D transforms to. And there are techniques to do that, so we'll cover that too. If you have opacity or filter, and you animate that using JavaScript, you'd better add the 3D transform because if you don't, the opacity and the filters are going to be computed in softer mode, meaning that the CPU are going to try to, the CPU is going to try to apply the drop shadow, for example. And drop shadow is not really a good example for things you want to do on the CPU. So if you have that, add the 3D transform too, it's going to help a lot. Also, during the animations, you don't want to move from non-3D to 3D. What that means is if you have a transform 3D property that you only apply for 2 seconds, you'd better apply it from the beginning of the animation. Even though it's just an empty transform like translate Z 0, Otherwise, you'll see a flicker that happens exactly when the animation moves from 2D to 3D. But if you have CSS animations or transitions, the browser will do that automatically for you. But you'll notice whenever the animation ends, your whole element is going to fade away and come back on. And usually it might have a different color space or look a little bit different. So whenever you see that, it's usually happening because it moves from the GPU to the CPU. So if you stick to one or the other, you'll get really good performance and also visuals. Okay, and the last one is avoid changing things like z-index. Also, this one is invalidating the whole tree of kids and try to resort the whole tree and figure out what needs to be displayed first and what not. And in order to avoid that during animations, there are times when you want to build things like the carousel. You can avoid it by using the preserve 3D on the parent. In that case, you can use the transform with a translate Z to move things in front or behind other things. And it's usually a lot faster than using z-index because it's going to be the compositor, which is really close to the GPU, is going to try to do that sorting. And it's usually really quick. It doesn't do memory allocations. It doesn't do anything. It just sorts them out, and it's really quick. Also, another way of doing animation, sometimes you really want to have assets that you want to animate. It's good if there's a technique called Spritesheet, and games have been using this for a long time. And the idea is that you put all your frames of the element in a big bitmap, then you can just display in sequence. And there are so many frameworks that do this today. One of them is EasyJS, for example. And what they do, usually they just, EasyJS, for example, is using Canvas, but I have an example here with using just CSS. What you can do is position all the frames on top of each other and set all the frames to opacity 0, and just the frame that you want to look at to opacity 1. And using request animation frame, you can advance the frame by just setting the next one to opacity 1 and the old one back to 0. I have a screenshot of a tool that I use to generate this animation that I have right now. And this tool it's interesting. This is Flash Pro CS6. I didn't know that it can actually generate HTML, which is pretty cool. You can use it to, if you have an old animation in Flash, you want to transport that to Canvas or to HTML, you can use that, and it's going to generate this big bitmap with all the frames in line. Some of the frames are rotated because they use less space in that way. And you can use that to generate also a JSON, which is kind of telling you at that point in the bitmap, you have that frame is rotated or not, so you can kind of use it. So what I did was, I have this demo in here where I have these guys where I can play with them. I can just move the animation by just cropping them from left to right, or I could just play them. And once again, I had the gestures in here. I couldn't stop myself just from using it. You see the one on the left, the pink guy here, is actually the exact same element. It's having exactly the same bitmap behind the scene. It's just that if I click it, you're going to see it's flipped using a transform. So it's using a scale x -1, meaning that it's going to flip to the other side. And not just that, I'm applying a filter. It's a hue rotation that is giving it a different color. So I think it's pretty cool that you have filters. Today we can do all sorts of variations on the client side. And also I have this debugging information. I can tap on these guys and I display the frame number. And you see some of the frames are rotated, so the number is on the other side. And also the bounding box is changing. And by the way, all of these elements are referencing the same image, but I'm using the background position to select exactly what frame I'm looking for. And also the rotating, the transform, I'm rotating it 90 degrees to get the exact way I want it to look like. Also, sometimes whenever you're doing animations, you want to remove content. And I've sorted them from the most common one to the least common one, but the first one is the least performant too. whenever you're removing the DOM, the element from the DOM, you're preserving memory, which is cool, but it takes a lot of time for the browser to actually detect that you removed something, and whenever you remove something, it might have triggered the change in the rest of the document. Things like if you had sibling selectors, for example, it will not have to figure out if some of the selectors are not invalidated now. If it had, for example, odd and even selectors, now it needs to figure out if those selectors are not invalidated because you removed the first item in the list. But you're not getting really very good performance with that. So there are other options to do it. Display none, for example, is gonna still keep the DOM memory for your element. So you still have your element parsed, your listeners are still there, it's still using memory. It's just that its layout is not done. This is still not as performant as we wanted during animation, so you may want to keep away from it. Also, visibility hidden. I told you about a way of removing the textures from the GPU. So visibility hidden is the way. Whenever you set that, the compilers say, this is never going to render, so I'm not going to use GPU memory for it. So whenever you see your browser crashing, you may want to go around your elements and see which ones are not really visible on screen and try to put visibility hidden on them. And it works really well. And the last one that you really want to use during animations is opacity 0. In that case, you could combine it with pointer events property that says whenever the user is clicking this, you should not, or you should ignore it because it's not visible. I don't want it to reach to get any events. And you can keep it in DOM. It's not going to affect anything. The GPU, the texture or the bitmap in the memory is still going to be allocated. So if you want to bring that up again, like 10 frames later, you can still do it with no performance issue. And that's exactly what I'm using for animating those guys, the Spritesheet we've seen before, and works really well. Another problem that we had in CSSFilterLab for desktop this time, so we had really good performance on desktop, but we still got the problem of the UI freezing, and that happened when we had this filter editor that allows you to really type your own shader, and it compiles it in real time, and it allows you to see the errors while you type. And in order to do that, what we did was to use a library called Angle. It's exactly the same library Angle uses to compile these programs in the native part. The only problem is that it's written in C++. So what we did was we used ence, an open source framework that cross-compiles from native to JavaScript. So the result of cross-compiling this library was 5 megabytes of JavaScript. So just putting that in the main thread had a UI freeze for at least 3 seconds on really good machines. So the solution for that is to move it to a different thread. So that means even the compilation itself of the JavaScript happens in a different thread. So you can still continue doing other stuff until the compiler is loaded. And most probably the user is not going to notice that while he types, the errors are not shown yet, but they're going to come anyway. It's taking 3 seconds, so it's not a really huge deal. But one problem, whenever you put things in the background, you want to make sure that whenever you're sending this message to the background thread, usually what happens is that you're sending jobs, things to do, things like compile this new program that the user just typed. But what happens, because the user types really quickly sometimes, you're sending lots of them. And some of them are not required, not needed anymore, because that's what the user had 3 seconds ago. So what you want to do is cancel the jobs that you just sent. So you want to keep some messages that are going to cancel the old things. And not just that, but sometimes you send a canceled message, but you still receive the one that just compiled 2 seconds ago. So you want to make sure that whenever you receive the results back, you're still up to date with the UI. So you're not displaying the errors that the user had 2 seconds ago when the line was not complete yet. And whenever you're working with worker feds, whenever I worked with it, I was thinking about it as like a server side that I was sending messages to and are receiving messages back. That's really what it is, actually. You send messages, you receive it back. It's just that whenever you have the thread, you're usually trying to send too many messages because it's just there, it's on the same CPU. The bandwidth is really high, so you're kind of forced to send lots of messages. So you need to make sure that everything works all right with that. And with that, I would like to thank you for listening. And if you want to see the slides, most probably I'll open source the whole framework, the touch interaction and everything in CSSFilterLab, most probably sometimes next week. So you either follow me on Twitter or go to our blog, and we'll have more blog posts about CSSFilterLab. Any questions? All right. Thanks.
Thank you, Alex.